A question that comes up all the time in practical situations is how can I optimize a situation? In other words, how can I find the maximum or minimum value and the values that give me that result? So in this lecture, we're going to look at two generic questions. I've got the first one here at the top. Then in the next lecture, we'll look at some physical situations and see how we can apply these results to optimize them. So my first question here is, if I know that the sum of two variables is constant, what's the maximum value of their product? And just as important, along the way, we'll find the x and y values that give me that product. Okay, so I'm talking about the sum of two variables, right? So I'm going to let x and y be my variables, and I'm going to let c be that constant. Right? So x plus y is equal to c. Right? So maybe I know, I have to have 100 meters in my final product. It's going to be made up of two different things. I can have more or less of each one, but they have to add up to 100. And it's the product that I'm trying to maximize, right? So I'm going to let P equal x times y. That's their product. Okay, so looking back at the original equation, I'm going to solve that for y. Right? If I move the x over to the other side, y is equal to c minus x. Now I'm going to take that and I'm going to substitute it into the product formula. Now this becomes P equals x times c minus x. And if I multiply that out, I get P equals negative x squared plus cx. And that's a quadratic equation. And most important, it's a quadratic equation that opens down, right? Because the leading coefficient is negative, which is good because a quadratic equation that opens down, it's got a maximum value at its vertex. And we know where the vertex is because we've got a formula for that, right? The vertex is located at x equals negative b over 2a. So here, my b is that c variable, it's the constant. A is negative 1. So if I substitute those numbers into my formula, x equals negative c over 2 times negative 1. And if we simplify that, we get x is equal to c divided by 2. Okay, so that's the x value, right? What about the y value? Well, to get the y value, I'm just going to take this and I'm going to substitute it back over here. Right? I've got the formula for y, right? Let's use it. So I put c over 2 in there. I get c minus c over 2, which simplifies to c over 2, which is really kind of a cool result. Right? What I'm seeing here is that maximum value occurs kind of at the midpoint, right? When the c grams or whatever it is we're measuring here is evenly spread between the two variables. So just kind of summarize this. The maximum value occurs when x and y are both c over 2, and that maximum product is c over 2 times c over 2, which is c squared over 4. So I've got a similar question here, but I kind of reversed things. Right? Instead of saying I know something about the sum and I want to come up with something about the product, in this scenario, I say, well, what if it's the product that's constant? Then what can I say about it? You notice this got reversed as well. What is the minimum value of their sum? All right, I'm going to start this off the same way. I'm going to say let x times y equals c, right, where c is our constant. And it's the sum that we want to talk about, so I'm going to say let s equal x plus y. Okay, well, I'm going to follow the same approach here, right? It worked pretty well for us last time. So I'm going to solve the first equation for y. If I divide both sides by x, that becomes y equals c over x. All right, then we'll substitute that into the sum equation, and it becomes p is equal to x plus c over x. Now here I'm going to do something a little weird. I'm going to factor that. It may not be immediately obvious that I can, right? But I'm going to factor it. So if I'm going to factor it like this, square root of x minus the square root of c over x, quantity squared. Now, that does not equal the original value, the original expression for p. Right? If you multiply that out, you get this. It's almost p, right? It's almost p. It's just got that minus 2 square root of c, that extra term in the middle. So what I'm going to do is I'm going to take this expression here, and I'm going to add 2 times the square root of c to it. Because that's going to cancel out that negative 1 that I've got there. Don't take my word for this, right? You can go ahead and multiply it out, simplify that expression, confirm for yourself that that does take me back to x plus c over x. Okay. Now, remember, I want to minimize this. Okay. X is my variable. It's the only thing I'm allowed to change. The c is a constant. So I can't change that 2 square root of c. This is going to be minimized when this expression here is at its minimum. Well, if you square something, it's going to be a positive number or 0. 0 is the smallest value that expression that I'm squaring can have. So that's where the minimum is going to occur. Right? So I'm going to take that square root of x minus the square root of c over x. I'm going to set it equal to 0. Okay, and now I'm out of room. So there's not enough room on here to squeeze in what we still need to do. So I'm going to go to a new slide. And I've got my original setup. I've got x times y is equal to a constant. I've got the formula for the sum, and I've got my formula for y. And here in the middle, I've got where we left off. Okay, it's not quite where we left off. I moved the square root of c over x over to the right-hand side. Okay, so now I'm going to square both sides. That's going to get rid of the square roots. I've got x equals c over x. Multiply both sides by x. This turns into x squared equals c. And if you take the square root of both sides, we get the result that I was looking for. The minimum value occurs when x is equal to the square root of c. Okay, how about the y value? All right, well, I'm going to do the same thing I did before. I'm going to substitute this back into my y formula. C divided by the square root of c, that's just the square root of c. So again, interesting result, right? It happened again that the minimum occurs when the x and y values are the same. And in a geometric sense, they have that same in the middle property that we saw when we were looking at trying to maximize the product, right? Where they are both the square root of the original. So again, just to summarize the results, the minimum occurs when x and y are both the square root of c. And if we substitute those back into the sum formula, we get the square root of c plus the square root of c, which is 2 times the square root of c. Okay, so I want you to hold on to those results, right? Just kind of put them in your toolbox. And in the next lecture, we're going to look at kind of some practical examples of optimization problems and see how we can apply these results to help answer those questions.